Hello, my wonderful learners. This is where we left off from our previous lesson. You were given 4 assignments to do. Today, as promised, I'm going to provide solution to the learner's assignment. And I will look at just the first 3. The first assignment read, the energy E of a photon depends on a mass m and velocity of light c. Form an expression connecting them using dimensional analysis. Take the constant k as 1. Great. From here, we need to identify the subject, which obviously is E. Then the dependent quantities are the mass m and the velocity c. From this, you form a relation between the quantities. And that will be E depends on the product of m, c. You then have to raise the dependent quantities to some powers. So I'm going to choose s and y. So m to the power s, c to the power y. Then you have to form a solvable equation by replacing the proportionality sign with equal to and a constant k. That will be E is equal to k m to the power s, c to the power y. The next thing is you write this in your dimensional form by easily enclosing them in a square bracket. That of the E, the k is a constant, then the m is written in the square bracket with the s outside, the c, then with the exponent also written outside. Let's take the various terms and expand them. The dimension of E in the question is energy. And energy is expressed dimensionally as m L square T minus 2. Next is the mass. And the mass has the dimensional unit as or symbol as a capital M. The next is the C, which was defined as velocity. Dimension of velocity is LT exponent negative 1. Let's then substitute into the equation. That will be for the E, M L exponent 2 T exponent minus 2 equals K. The mass, the capital M exponent S. The C, LT exponent negative 1 the power Y. The next thing is we expand. So the left hand side remains unchanged, but the right hand side needs an expansion. And this power will be M exponent S with the L to the power Y, then the T to the power negative Y. When you expand, that is what you get. Okay. We go on by keeping the left hand side as it is. The right hand side multiplies as M to the power S, L to the power Y, T to the power negative Y. Let's then compare common terms on both sides. So let's start with the M. On the left hand side, m has a power of 1. But on the right hand side, m is to the power s. Since the bases are the same, then the exponents are also equal according to the law of indices. So we could simply say the value of s is equal to 1. Looking at the L, comparing the L, that too, you could say on the left hand side, L is to the power 2. On the right hand side, L is to the power y. Since the bases are the same, the exponents are also equal, and that will also amount to y equals 2. Remember, we are looking for s and y. So just by comparing the common terms of m and l gives the answers we want. That means that you could go ahead with the t, but since you have s and y, that is what we need. Let's then substitute this to the equation to form an expression that connects the various terms. I'm going to use this equation. That will be E equal to K, M to the power S, and S is 1, C to the power Y, and C is 2. But we are told that K is equal to 1 from this part. So this will be the expression. E equals, this is 1, so M exponent 1 is still M, then C exponent 2. This is the expression as we are told to do in the question. And as you go higher into physics, this is the Einstein's equation that you just proved. Let's move on to question number 2. Assignment number 2 reads, the potential energy U of a body depends on the mass m of the body, its acceleration of free fall g, and the height h above the ground. Using dimensional analysis, form a relation that connects the terms. From this as well, the subject of the statement is identified as the potential energy U. The dependent quantities are the mass m, the acceleration of free fall g, and the height h. From here, we then build a relation between the quantities. That will be U depends on the product of m, g, and h. We then raise the dependent quantities to some powers. So that is the process we have been following all this while. So U, I'm going to use SYZ. So m to the power s, g to the power y, and h to the power z. We then form solvable equation by replacing the proportionality sign with equal to and the k. That will be m to the power s, g to the power y, h to the power z. Let's write this in their dimensional form by simply enclosing them in a square bracket. Okay. So g to the power y, h to the power z. Let's look at these terms into detail. The first one, being the U, is said to be potential energy. So that means energy. And the dimensional unit or equation of energy is m L exponent 2 T exponent minus 2. Then the m, which is obviously mass, a dimensional symbol is a capital M. The next is the G, which is said to be acceleration of free fall. So simply acceleration. And that is LT minus 2. Then the H being height. Height expresses a length, and that means it is an L for a dimensional symbol. Let's then substitute into the main equation and solve. That will give us for U M L exponent 2 T exponent minus 2 equals K for the mass, capital M exponent S, for the G, LT minus 2 exponent Y. Then the H is an L exponent Z. With this, the left hand side remains the same, but the right hand side is expanded as M exponent S. This Y here goes for both the L and the T, so that will be L exponent Y, T exponent minus 2Y. And the last one, L exponent Z. Maintaining the left hand side, we then expand for the M. It will still be M exponent S. On the L, there are two of them. One has an exponent Y and the other has an exponent Z. Since they are multiplying, one of the bases is written, but the exponents are added as Y plus Z. For the T, it goes to the power negative 2Y. The next is comparing the common terms from both sides. Let's start with the M. For the M, on the left hand side carries a power of 1. On the right hand side, it carries a power of S. And since the bases are the same, exponent could be said to be equal. So S is equal to 1. That is it. Let's consider the other term, that is L. On the left hand side, L is to the power 2. On the right hand side, it has Y plus Z. So this as well, since the bases are the same, the exponents are also equal, and that generates an equation as 2 equals Y plus Z. Let's refer to this equation as equation 1. Considering the T, on the left hand side, T carries negative 2. On the right hand side, T carries negative 2Y. From this context, we can also say the exponents are equal since the bases are the same. And that will be negative 2 equals negative 2Y. Let's then find Y by dividing both sides by negative 2. And after possible cancellations, you could arrive at Y being equal to 1. Okay. So look at it closely. We have found S and Y. The next thing to find is the Z. So from equation 1, the equation we just called equation 1, from that equation, we could go ahead and solve for Z, because you have 2 equals Y, and Y is now 1 plus Z. From this context, you could simply say 2 minus 1 equals Z. Therefore, Z is equal to 2 minus 1, and that is also 1. Now we have been able to find the value of S to be equal to 1, Y to be equal to 1, then Z also to be equal to 1. With that in mind, let's then form the relation that connects the terms. From our main equation here, we could then say U is equal to K, then M exponent S, which is 1, G exponent Y, which is 1, then H exponent Z, which is also 1. So simply U equals K, M, G, H. We're not told what the value of K was, so this is the expression. But if we were told K was equal to 1, then that will be left up with M, G, H. That's on condition that K is 1. And this is the true formula for finding the potential difference. Thank you. Now to question number 3. Assignment number 3 reads, the fundamental frequency F of vibration of sound in a stretched string depends on the length L of the string under a tension T and a linear density mu. Using dimensional analysis, show that the terms are related by the expression F equal to 1 over 2L square root of T over mu, where K is equal to 1 on 2. From this, the subject is the fundamental frequency F, and the dependent quantities are L for length, T for tension, and the mu for linear density. We then build a relation between the quantities as F depends on the product of L, T, and mu. We then raise the dependent quantity to some powers. F is related to L exponent S, T exponent Y, mu exponent Z. We form solvable equation by replacing the proportionality sign with equals to and a constant K. That is K, L exponent S, T exponent Y, the mu exponent Z. Let's write them in their dimensional form by simply enclosing them in a square bracket. The K is dimensionless. So this becomes L exponent S, T exponent Y, then the mu linear density exponent Z. Expanding the various dimensional equation, the F is said to be frequency. And from our table that we looked at dimensional equation, frequency is T exponent minus 1. The next is L, which is length of the string. And length has its dimensional unit or symbol as a capital L. The next is the T, and this T is called tension. So don't confuse the T with time. This is tension. Tension is a force, and the dimensional equation is M LT minus 2. Then the last part is the mu, which is said to be linear density. Great. So earlier we looked at mass density area density, and linear. The linear is ml exponent -1. It is also called mass per unit length. Let's then substitute into the equation. For the frequency, let's use this equation. For the frequency, it is T exponent -1 equals K. That of the L is a capital L, the power S. The tension, M L T -2, the power Y. Then the last is the mu, M L -1 to the power Z. Great. The left hand side remains the same. Then let's expand the right hand side. That will be L exponent S. The Y is for both the M, L, and T. That will be M, the power Y, L, the power Y, T to the power -2Y. And the last become M to the power Z, then L to the power -Z. Great. Let's continue with the expansion of the right hand side. Now picking it from the M, or you can also go with the L, no problem. So L, you have L to the power S here, L to the power Y, the L to the power -Z. Since they are all multiplying, the exponents are then added, and that will be S plus Y minus Z. That is for the L. For the M, this has M to the power Y, the M to the power Z. And because they are also multiplying, the exponents are added as Y plus Z. And lastly, the T, you have only -2Y. Well, this is the expansion. From here, let's compare the common terms on both sides. Starting from the T on the left hand side carries a -1. Okay, that is T as per -1. But T on the right hand side carries a -2Y. In this context, you can have an equation as -1 equals -2Y since the bases are the same. The exponents are also equal. To find Y, let's divide both sides by -2. After cancellation, you will end up getting Y to be equal to 1 on 2, half for Y. Let's go to the next term. That is the L. On the left hand side, there is no L. And so we say, even if there is, it is to the power 0. Kindly note this for me. There is no L, and so we still write it with the power 0. And in indices, any number raised to the power 0 is 1. And it's equal to, on the right hand side, L carries the exponent S plus Y minus Z. This then generates an equation like 0 equals S plus Y minus Z. Let's call this equation as equation number 1. Since the values of S and Z are not known, though we know that of the Y, we could go ahead and also compare the terms for M. On the left hand side, M has no exponent, or there isn't any M. And so that is also written the power 0. And on the right hand side, you have m to be the power y plus z. You then form an equation 0 equals y plus z. However, don't forget that y has already been found to be equal to 1 on 2. That is the y. So we could simply go ahead and find out of the z, saying 0 equals half for y plus z. The half move to this side to get 0 minus half equals z. Therefore, z is said to be equal to 0 minus half, giving you negative half. I hope you have noted this as well. So far, we have been able to find y to be half, then z to be negative half. Let's then find the value of s from equation number 1. And all we need to do is to substitute for y and z into it. That will be 0 equals s plus that of the y is half. Okay. Then that is a minus z. So minus of the z is also carrying a negative. Kindly take little caution here. It is negative z, but the z is negative half. So that will make sure there are two negatives meeting. So 0 equals s plus half. This negative and that negative will form positive half. So 0 equals, from your calculator, you could simply punch the addition of half plus half, which obviously is 1. So that is the value. Great. So this is equal to s plus 1. This then moved to the other side to get 0 minus 1 equals s. Therefore, you can also say that s is equal to negative 1. So far, you can conclude that s is negative 1, z is negative half, and y is positive half. With this, let's try to show the relation between the terms as expressed here. Let's not forget our earlier equation, which said f equals kl exponent s, t exponent y, mu exponent z. Let's now use this to try and see whether we arrive at what we are given. And I trust that surely we will arrive at that. So let's substitute. F equals k. The k is said to be 1 on 2. The L to the power s, which is negative 1. And t to the power y, that is positive half. Then mu to the power z, negative half. Great. Let's not forget that L to the power negative 1 means 1 over L. So that is F is equal to 1 on 2 times 1 on L. Then t to the power negative half simply could be written as square root of t. So take this from indices. The square root of a number is the same as that number to the power half. Okay. This can also be written as, first, because of the negative, it could be written as 1 over mu the power half. This is how it is written. If that is understood, then in the place of the half, we could easily replace it as square root. So this is the way of converting all of this to that. Now let's multiply. Taking the numerator, 1 times 1 times root t times 1 will be equal to 1 root t, or simply root t. You have root t here and 1. All of this over 2 times L will be 2L square root of root or mu. Reorganizing it, we'll have F is equal to 1 over 2L. Then, because these are all having square root, you can have a bigger square root and write them in it. That will become T over mu. And this is exactly the same as what we have been asked to prove. So this ends our lesson. I believe it has been an interesting one and a long journey. But thanks that you have followed up to this far. And I'm highly enthused about how you have responded to this lesson. I wish you all the best and stay blessed as we continue next time.